So we talked a little bit about the identities. Um, and then on 33, there's it's showing the range of values for sine and cosine. Notice that they go from -1 to +1. Tangent and cotangent can be any values, any real number. And then secant and cosecant are going to be -1 to -infinity, 1 to infinity, but it will not be anything between -1 and 1. So that's one of the things. There'll be some problems on that. Then the Pythagorean identities, and just a little comment about that. That Pythagorean identity, if you're going to learn it, all three of those identities are from this identity. That says no matter what the angle is, if you take the sine squared of the angle plus cosine squared of the angle, it's always 1. So it don't make any difference what angle it is. And then if you divide this by cosine squared, then notice that this value becomes 1. And this is 1 over cosine squared, and this is sine squared over cosine squared. You actually get that second identity, tangent squared plus 1 equals, and 1 over the cosine squared is secant, and so it's secant squared. So this identity is just this one divided, each term divided by cosine squared. You see that? Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared. Then if you take this identity and you divide it by sine squared, then what you get is 1 plus, and then it'll be cotangent squared equals, and then 1 over sine squared is cosecant squared. So what I'm trying to tell you is that if you learn this one, you got all three of it learned. Because the rest of them are just, do you see that? Okay. Then it's talking about the quotient identities, the tangent of an angle is the sine of the angle over cosine of the angle. Now remember that tangent was y, tangent is y over x, and sine is y over r, and cosine is x over r. So if you invert this and multiply, you get that. That's where the identities are coming from, right? You see that? And then cotangent is just the invert of the tangent. So when you talk about this, cotangent is 1 over tangent, and then that's the invert here, cosine theta over sine theta. These are really fundamental identities and things that you should just, over the course of your trig experience, you should be able to just not go back to a sheet to find them. It just should be recognized. Particularly this one, and this one, and these, and then this cotangent 1 over tangent. You should just automatically kind of know those. And you'll deal with them enough, I think, that you won't have difficulty with them. Now let's look on page 37 at the problems. And it says that use the appropriate reciprocal identity to find each functional value. Rationalize the denominator when applicable. So if we do number 4, and that's cosecant theta. We want to know what that is. Well, the identity we're going to use is cosecant theta is what? 1 over sine. And notice that sine theta is given to us a negative 8 over 43. So then we just substitute in here 1 over negative 8 over 43, and that you invert, so it's a negative 43 over 8. So the answer is, and we're using this identity. What identity would we use in number 6? Want cotangent, and it's giving us tangent, right? So we're going to get cotangent is what? 1 over tangent. Because see, they're giving us the tangent theta is 18, right? So we plug it in here, and this is 1 over 18. So now when they talk about rationalizing the denominator, that's saying that if there's a radical in the denominator, then you get rid of the radical. Well, this is not a radical. This is just a fraction, so we don't rationalize anything there. Oh, number 10 would be one where we'd have to rationalize. They want to know what the sine of theta is. And they've given you what? Cosecant square root of 24 over 3. So what's the fundamental identity? Sine theta is what? 1 over cosecant, right? So then you put this in there, 1 over the square root of 24 over 3. You invert and multiply, that's going to be 3 over square root of 24, right? And then what do we have to do? Rationalize the denominator, correct? And how do we do that? Multiply square root of 24 times the denominator and square root of 24 times the numerator. This, what's in red, is 1, so we haven't changed anything. We're just getting the denominator to be not a radical. It's going to be 24. And the numerator is 3 times the square root of 24. So our answer is 3 square root of 24 over 24. Now what you do is you would reduce this, and then you'd do the square root of 24 over 8. Yeah. Okay. So that's how you're going to do those problems. Now, the next group of problems, 19 through 30, says determine the signs. That is, determine whether it's positive or negative, the trigonometric functions of the angle and standard position. So I'm going to try to just do this all in one. Shot. Remember, the initial side's always here, and then you'll determine what the functions are. Now this is what you should remember, that in this quadrant the x is what? Positive, and the y is positive. And then we go what? Negative, positive, and then negative, negative, and then positive, negative. Now remember that in general, sine of any angle is going to be y over r. The cosine of any angle is x over r, and the tangent of any angle is y over x. And then cosecant's the invert here, secant's the invert here, and cotangent's the invert here. So r is always what in every quadrant? Positive. So the sign, whether the sign is positive or negative will depend upon what the y value is, right? See that? So in the first, anything that's in the first quadrant, the sign of an angle that has terminal side in this quadrant is always going to be what? Whatever the y is, and that's always positive, right? That's always greater than or equal to 0. The cosine in this quadrant will depend upon the x value, and the x value is always what in this quadrant? And the tangent is going to be y over x, but those are both positive, so it's always positive. Now in this quadrant, the sine of the angle is going to be a positive value over a positive value, so it's always what? Positive. The cosine of an angle whose terminal sides in that quadrant is going to be x over r. The x is always negative and the r is always positive, so what is it here? Right? You see that? And then the tangent of an angle whose terminal side is here is going to be y over x, and those are going to be opposite sides, right? So what's it going to be? Always negative, right? You see where I'm? So down here, sine is going to be what? What's y? Negative. Cosine is going to be, tangent's going to be positive, y over x. And over here, the sine is going to be negative, cosine's, and the tangent is. You see how it goes? And then for the cosecant, it's going to be whatever the sine is, right? The secant's going to be whatever the cosine is, and the cotangent's going to be whatever the tangent is in terms of plus or minus, right? So now all you have to do is determine which quadrant our terminal side is in. Does everyone follow? I mean, that's the simple part of this. So 20, which quadrant are we in? We're in the first quadrant. So what is true about all of our trigonometric functions? They're all positive. So 22, which quadrant are we in? Third quadrant. 195 is down here. And so what is our sign going to be? Negative. And the cosecant's negative. Cosine is negative, and secant is, tangent is, and cotangent is. Does that make sense? Sure. Does that make sense? It's just, that's how simple it is. You just determine the quadrant, and then you can just automatically tell whether it's positive or negative, because those trigonometric functions in those quadrants on terminal sides are always going to be that way. So that's all I'm going to talk about on those sets of problems. All right, the next set of problems, it says identify the quadrant or possible quadrants of an angle theta that satisfies the given conditions. Now we're using the information we just talked about before. And let's look at number 32. Now the cosine of theta is positive, right? That says positive. Now which quadrants is the cosine positive? 1 and what? Which quadrants are the x values positive? Okay, so it's this quadrant and this quadrant is what satisfies that condition, right? Now I'm going to go to the next one. It says secant is positive. Now, turn your secant into its equivalent reciprocal identity. Secant is what? 1 over cosine, right? So it's saying 1 over cosine is positive. So which quadrants is this true? 1 and 4. So the answer is quadrants 1 and 4. Does that make sense? You take each one and you say, where is it true? Then let's go to (38). It says cosecant theta is positive. Now, what I always do, rather than remember, all I have to do is learn cosine, sine, cosine, tangent, right? Then the other ones, I just do the reciprocal identities. Cosecant is what? 1 over sine. So it's saying 1 over sine is positive. Where is that true? In what quadrants? Where's the y value positive? 1 and 2, right? Right? Do you see what I'm... Where is the y value positive? Because the y is related to sine, and you know these is all sine. So it's in 1 and 2. Now then, 38. It says cotangent is positive. Now, cotangent, in order for that to be positive, what has to be true about the y and the x? Same sign, right? In which quadrants is the y and x the same sign? 1 and 3. So in which quadrants are both of those true? So here's your answer. See how you do it? You take each one, identify which quadrants it's true in, and then see where the overlap is. Does that make sense? Let's look at number 40. These later ones will give us a little bit more of a challenge. Cotangent theta is negative. So what is that? You always go back and think of the x and the y. What has to be true about x and y in order for cotangent to be negative? Okay, they have to be opposite signs, right? And that is true in 2 and 4, right? Now, the next one says secant theta is negative. Now, I would go back because it's easier to identify the sine cosine. What's the reciprocal identity for secant? 1 over cosine. Now then, cosine is actually what it's going to be, something over r. Is it the y over r or x over r? It's x over r, so it's negative. So in which quadrant is this true? Okay, so it's 2 and 3. Now where is the answer with both of those? So it's number 2. You see what? It's usually easier to convert everything to sine and cosine using all your reciprocal identities, and then convert into the x and y and the ordered pairs. It's all the x and y will, those coordinates are going to give you the value of the sine cosine if you just learn those ratios. And it's pretty logical, right? You just the next problems. Now these problems are related to the table on page 33. Now, notice that sine and cosine go from -1 to +1. You cannot have any value, when you take a sine of an angle, you can't have a value greater than 1 or less than -1. It has to be between the two. The tangent and cotangent can be any real number. And then the secant and cosecant, which are related to sine and cosine, notice that what they're saying, sine and cosine go from -1 to 1. Now secant is the outside of what that is, and cosecant, right? It's -1 to -infinity, +1 to a +infinity. So it's outside of the range of sine and cosine. Is that? Now, what you want to do is it says decide whether each statement on page 38 is possible or impossible for an angle theta. And we're going to take a shot around the room and see what it. And Chris says, Sharp says, I know I'm first. 45. What is that? Sine, it says sine theta equals 2. Is that possible?
So are we looking at like 2 as an angle?
No. See the values back there on page 33. That table says that the sine and cosine can only be numbers between -1 and +1. See on page 33? You see that top row says, on the left hand side says sine and cosine, and if you look at the far right, both the middle column and the far right column says you can only have values from -1 to +1. So go back to our problem 45.
So it's false.
That's right. It's outside of that range. Does everyone see? Nicole, 46. Okay, that's false. 47, Elizabeth. Okay, that is possible. 48, Devin.
48?
Yep.
What's that? That's possible.
Okay, because it's between a -1 and +1. Chris Jensen, 49.
The real number is not supposed to be a full number, so.
No, it can be any real number, tangent, cotangent.
Okay.
So is it
That's
possible?
like a whole number, not
Yeah.
a real number.
Yeah, but it says back on the table, it says it can be any real number. -infinity to whole. So then it is possible, right? Okay. 50.
The same as the previous one would be possible, right?
Okay. That sounds like a question, not an answer.
No.
Okay. All right. All right. 51, secant. What does it say about secant and cosecant? Can it be values between -1 and +1? If you look at the table, can it be? It's not. It can't be. See, the sine and cosine can only be values between -1 and +1. The secant and cosecant have got to be -1 +1 outside, right? Sine cosine's between. Does that make sense? So, you think about it, sine cosine are related to secant, cosecant in the inverse relationships. So sine cosine's between, then the other ones have to be on the outside. And both of them include -1 +1. Because you invert -1 and +1, you get -1 +1, right? But once you start inverting a number, a number less than in absolute terms 1, then you get a number greater than 1, right? So 1 inverted is 1, and then the secant, cosecants, which is the inverts, become large numbers, and the sine and cosine become numbers between 0. All right. Everybody gets a chance. So where are we at? Who's next with what problem? Huh.
That is not possible.
All right, very good. 53, Greg. All right, 54, Corey. Okay. You need, oh, let's see, let's go down to some of them double ones. I guess it's unfair that you get to start and you get to go to the hard ones. So I'll go 55, you can do it. Chris.
Oh, we're doing 55?
Yeah.
Possible.
Okay, 56, Nicole.
Not possible.
56 is cotangent, isn't it?
Yeah. Oh, it is possible.
Okay. 57, Elizabeth. Okay, so the sine can be between -1 and 1, and the cosecant has to be outside of that. So that's possible. Devon, 58.
Oh, they're both possible.
All right, 59, Chris Jensen.
Not possible.
Okay, they're backwards, aren't they?
Well, the cosecant,
If the cosecant were -1 and the cosine were 1/2, then it would be possible, right? They've assigned them backwards, correct?
well, doesn't cosine -2 work because it's less than 1?
No, it has to be between -1 and +1, so it's decimal. It can absolute value of 1.
Gotcha. So you have to.
Yeah. 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 But the assignments are just backwards, right? Okay, the next group says use identities to solve each of the following. So let's look at 63. 62. 63 is something that probably has an answer in the back. Sine theta, and you're given cosine theta equals 4/5. Okay, they want you to use identities. So which identity relates sine and cosine? Like on 35, what's that? Well,
Bullshit.
if you look at 35, do you see the Pythagorean identities? Which one of those is related to sine and cosine?
Bullshit.
Now, it is the sine squared plus cosine squared equals 1, right? If you're going to use identities to do this. Because it says use identities to solve each of these. So what the identity is that you're going to use is that sine squared plus cosine squared equals 1. And how can you get this information so that you can get sine out of that thing? So if you go sine squared equals 1 minus cosine squared, sine is going to be what? Square root of it, right? You notice it's saying on page 62, it's saying you're in quadrant 4. This is a plus or minus, right? So if you're in quadrant 4, which are you picking? Is Y positive or negative in quadrant 4? Negative, aren't you? So this is what you're going to pick. A negative. And then you're going to substitute your value. And what value was that? 4/5? Now this is 16 over 25. I got to get 25, right? 25 over 25. I'm going to have to do this one and get a common denominator. Because this one is going to turn into 16 over 25, right? When I square it. So I got 25 minus 16 over 25, which is a minus the square root of 9 over 25, which is a minus 3 over 5. Now I'm doing it the way they want me to do it. There's easier ways to do that, figure it out. But I'm using the identities to do it. And that's the identity that you'd have to use. You couldn't use tangent as sine over cosine because you don't know what tangent is. You know what sine is. You can't use cotangent. You can't, you know, and the other ones won't give it to you. It's just that one. All right. 64. They want to know what secant is when you're given tangent. Now, which one of those identities that were given to you relates secant with tangent? You see the Pythagorean identity again? So if I just kind of reverse the order, the secant squared is 1 minus the tangent, 1 plus tangent squared. Right. And then I can get secant by taking plus or minus the square root here. But now, which do I pick, the plus or the minus? Which quadrant am I in? And in 3, both x and y are what?
Negative.
Negative. Okay. I thought I heard someone say positive, but I think I just misheard. Secant is 1 over cosine. So this you're going to select what? Negative here. And you're going to substitute in negative, and that's going to be square root of 7 over 3 quantity squared. Now I'm going to have to build this one, right, with a 9 over 9, because this is going to be 7 over 9. Which is the negative, the square root of 2 over 9, which is negative square root of 2 over 3. And that was secant, right? So that's what they're wanting you to do, use those identities, figure it out.
You go over, real slowly, how you're supposed to grab the, positive and negative.
Okay,
You get right there where you.
you can see right, this is where I'm getting it from, is 64. The thing I didn't write down is it says it's in quadrant 3. And in quadrant 3, technically, the XY is negative, negative. So the sine cosine are negative, negative. The sine is related to the Y and the cosine is related to the X.
I think you have an addition here.
Yeah.
Did I add, where did I add?
It should be where it says.
Oh, this is supposed to be plus,
It's supposed to be plus.
set 16. Okay, I subtracted. I didn't add, I subtracted. Thanks. This should be 4. Sorry. Sorry. I was subtracting. Did that help you? All right. But see, what am I trying to calculate? The secant. And the secant is what I want the sign for. You know, I want to know whether it's positive or negative. And the secant's related to cosine. It's 1 over cosine. And in this quadrant, cosine's negative. This is, you are right, that this turns out to be a positive number. But what I'm doing is this calculation is to solve for what secant is. All right? I didn't, on the problems, like the information is this is what they're asking for, this is what they're giving, these two things. This will determine which you pick up here. And this will be used in your identity substitution. Is that good? You want to see another one? We got to get through this next stuff so that you have the information so that you can study for the test. But I could come back and look at that if you want. The next one says find the remaining trigonometric function values for each angle. All right, let's look at 70. It says a cosine theta is a negative 3/5. And then you're in quadrant what? Quadrant 3 is going to tell you what? The sine's negative, the cosine's negative, and the tangent is positive, right? Because x and y. In quadrant 3, the x is negative, and it's related to which one, sine or cosine? Cosine. The y is negative, and it's related to sine, and then tangent is the ratio of y over x, so that makes it positive. Do you see what I'm doing? And so then you can get the cosecant is related to sine, right? So whatever sine, whatever positive or negative the sine is, cosecant's going to be that. The secant's related to cosine, whatever cosine sine is, plus or minus. Secant's going to be the same, and then tangent is going to be the same as cotangent, or cotangent's going to be the same as tangent. Okay, so that's for establishing the sign. Notice the cosine's negative 3/5. That follows with this, right? And if the cosine is negative 3/5, what inverse or trigonometric function can we automatically get? Secant, right? So from this, comes automatically, secant of the angle is going to be a negative 5/3, right? It's the reciprocal. Now what we have to do is get cosine tangent and then do the reciprocal stuff over here. So if we just concentrate on getting the sine and the tangent, these will automatically fall out, right? Now the question is, how do we get the sine from when we're given cosine? Well, the information we've been given so far, we're going to use identity. So which identity do we use? The sine. We're going to use this identity, are we not? We have to use the identity if we're going to get sine that has only sine and cosine, and that's the only one that has that. So we isolate the sine, and then we get it just sine by itself by doing plus or minus the square root, right? Remember that this is the square root principle. If you get a squared equals something, then you can take the principal square root here and take plus or minus the square root there. Remember that from algebra? Square root principles. Now we're saying which one of these is that sign when it's in that quadrant? It's negative. So we say what we have is a negative. And then we substitute in the value 1 minus, and what are we going to substitute in for cosine? Negative 3/5 the quantity squared. So we got a negative square root of, what do we have to build this 1 to? 25, because when you square this, it's going to be 9 over 25, right? So we've got to build this to a fraction of 25 over 25 minus 9 over 25. And this is going to be 16 over 25 4/5. And that's sine. Negative. So we have a negative 4/5. So what's related, what's its inverse? Okay, it's cosecant theta is a negative 5/4. And then tangent, so what we're going to use tangent, we're going to use the identity of what? Sine over cosine? And that's going to be 4/3. And then cotangent, we're going to think of that as what? 1 over the tangent. It's the easiest one, and that's 5/4. That's 4/3. Okay. And this is 3/5. The 5/4 looked like awful familiar right there. This is supposed to be thirds. 3/5. Doing everything screwy. 3/5. This is 3/4. Golly. This is 4/3. This is 3/4. I know it. Jeez. So this problem is going to be a lot easier because there's a right triangle. When you get to right triangles, it's 3, 4, 5 triangle. You don't have to use all these identities because a right triangle. When you get to it, right triangle trig. if this side's 4, this is 3, and this is 5, and the tangent is always, opposite side, tangent, if this is the angle, it's 4/3. And if you go to cotangent, it's 3/4. And when you see this, whenever you'd see this, you'd say that's a 3/4/5. And you'd automatically know that the sign's going to have a 4. This is going to become really easy as we go. That's all I'm saying. Right now, this is what you got to work with, and that's the way you're going to have to work it.
That sounds extraordinarily lazy.
What?
I know it sounds extraordinarily lazy, but on the problem where it gives you the tangent, if you just reverse engineer the X and Y and then get the distance out of that and then get all your identities, So.
Do you have an example problem that I could?
I like that one right there where it said, I'm pretty sure they think of you, this one's 64, where it says your tangent is √7/3. You know that √7 is going to be y and 3 times x.
Yeah.
You map it out.
What you could do, you could find R by squaring those two terms, summing them together, and take the square root, and you could get R. And then you could do, like the square root of 7/R as sine, and the 3/R as a cosine. That's another way of doing it. But see, they're not telling you to do it that way. They're telling you to use identities. There's many other methods that you could use to solve it. But, what's the instruction? It's to use the identities that's presented in this section to do it. There's nothing wrong. If you get the right answer, if you can figure it out by doing what you're talking about and get the right answer, there's nothing wrong with it. But it's just like, how do you use the identities to do it? And that's what this is about. So when you look at this thing, and I'm just telling you, when you see there's this quadrant trig that we're dealing with, where you're dealing with X and Y's and R's. Then there's right triangle trig. Well, right triangle, there's standard right triangles that you talk about, and one of them is a 3-4-5 triangle. So anytime you see a 3 and a 5, in a cosine, or a 4 and a 5 in a cosine, then you know the other one has to be, it's a 3-4-5 if the denominator is 5. And then you can just automatically figure it, so you don't have to do all the process. Then that part of the problem is just simplified, and then it's part of another bigger problem. And see, this whole thing, what you can do if you're doing in surveying, or if you're doing in similar triangles or trying to solve it, is usually what you do is you have a smaller one and you're trying to relate it to a higher one. Like a tree problem, you say, how tall is a person? What's the shadow cast of a person? What's the shadow cast of a tree? And then you can do similar triangles and figure it out. And the ratio is always the same. And then you can do the angle. You can turn angles to get it. And then the sine is going to be the, opposite side over hypotenuse, and the cosine's adjacent side over hypotenuse, and you're going to learn that. So it's all part of this. Trigonometry is quadrant trig, right triangle trig, then it's going to be unit circle trig, and then it's going to lay it out as a sinusoidal curve trig, so that you can do lots of different things. Sinusoidal trig that's what sinus rhythm is for a heart monitor. That's trigonometry. That's how that converts. It converts the rhythm into sinusoidal curves and then runs it out. All right.